Okay, three angles. So the top angle, if you follow it along the edge right here, is angle BAC. Okay, it takes three letters to name an angle. The middle one is the vertex where it changes directions. Okay, now what about that bottom angle? What's the name of this bottom angle? CAD. All right, angle CAD. And then your last angle is the whole thing. So what is the name of this big old angle? Mr. G. That one didn't land. All right, well, anyways, BAD is the big angle. Cool? Everyone good? So we're going to do some notes on angles. So mixture, pass this back. Ready? Dang it. Dropped my pen. All right, here we go. If I can pull this up. There we go. Angles. So how do you make an angle? By the way, hopefully you went over some of this vocab on your own. You looked it up or something when you did the color by numbers yesterday for the sub day. But let's go over it officially here. An angle is formed by two rays. Okay. If you don't remember, we did talk about this on a warm-up. Rays go one direction with one arrowhead, wherever. Okay. And they have a common endpoint. Okay. So this common endpoint where they both touch, where it changes directions, is called a vertex. Okay. And those rays are called the sides of the angle. So you got two rays where they touch is the vertex, those are the sides. And you name an angle using three letters, just like our warm-up today, right? The middle letter must represent the vertex, right? Oh, wait, so what is the name of this? Angle what? ABC. B is the vertex in the middle, right? Where it changes directions. All right, now here's another thing. We talked about this. If you have an angle all by itself, then you can use a single letter if it's the only angle that you can see. So since that's the only angle, I could also just call this angle B. That works out, okay? Now, when referring to the measure, when I say measure, how do you measure an angle? When you measure in degrees. Y'all know that? Like 90 degrees, 180 degrees, okay? But when you're writing it out, you use a little lowercase m for measurement. Measure of angle ABC is, as you can see here, 60 degrees. So whenever we use a little m, that means measurement of the degrees. Cool? So far, so good? Look at the next part. Now, let's start with the one that should be known by all. This third one, what do you call this type of angle? When it has that little box. Y'all know what that means with the little box? Right angle is right. It is so right. Okay. How many degrees is a right angle? Do you know? 90 degrees. Okay, hopefully this is old news. So it equals 90 degrees. That's cool. But do we know what we call it if it's less than or greater than 90? So, first one, you'll see how this angle is less than 90. If it's less than 90, we call that acute. Okay. I think of acute being a smaller angle, just like acute sounds like the word cute. Okay, like small things can be cute sometimes, right? So acute is less than 90 degrees. Less than 90 degrees. All right, now the big one, bigger than 90, it's very wide. The word sounds big, obtuse. Okay, it's big, obtuse. If you have an obtuse angle, okay, instead of being less than 90, this one's going to be greater than 90. Okay, and then what do you think that last one is going to be called? It's straight, because it makes a straight line. Straight angle. And then how many degrees is that straight line? 180 degrees is correct. It's like two 90s next to each other. They make a straight line. Okay. So those are the types of angles that you got to know. Sorry. Let's do example one. Can you name the vertex in this angle? Okay, it is K. Point K is where it changes directions. It's the corner. It's the vertex. Okay. What do you call the sides of that angle? So remember, these are the rays that make the angle. What's the name of this top side here? KL. And since it has one arrowhead, you put a one arrowhead ray on top. KL with a ray. And what's the other one going downward? K towards J. It's also a ray, so I put the ray on top. So KL is one, KJ is the other. Go with me. Make your heads up, please. Now, those are your two rays. Those are called the sides. Now, how can we name this one angle? What's one way we can name this angle? What three letters make that angle? Okay, L to K to J works. You can also do it backwards. So, angle JKL. And also, since the angle is by itself, what can you just call it? Angle K. Only if it's by itself. So if you think back to our warm-up, it was not by itself. There was like three all stuck together, right? But if it's all alone, you can just call it the vertex. Now, letter D here, classify the angle. Is this greater than, less than, or equal to 90? What do you think? It's wider, greater than 90. So what do you call that? Like we know up here, we call that obtuse. Larger, okay? Now, example 2, what do y'all think? What's the vertex? S, right? And what's the sides? SR and ST. SR and ST, okay? Say what? Okay. Now, to name the angle, is that what you're saying? So yeah, to name the angle, I'd say three letters in a row. RST, the middle letter is the vertex. So angle RST is one of them. You can also flip it, right? Go with me? Without phones. So flip it around, it's TSR. And since it's by itself, what can I call it? Angle S. Cool. Now, how would you classify this looking at that little symbol right there? 90 degrees. Okay. So it's right. And that's right. What do you notice about these two angles down here? You see how they're the exact same measurement? Okay. If they're the exact same measurement, okay, like it says off to the side here, that means they're going to be congruent. Okay, equal measure, congruent angles. That's how it works. All right, so if the measure of angle A equals the measure of angle B, if the little measurements are equal, okay, then those angles are congruent. This is written with a congruence statement, okay? So your statement is going to have the little congruent symbol with the squiggle on top. So angle A, congruent, angle B. So again, look, equal measures means congruent angles. Make sure you have this down, and then we're going to flip to the back page. We're going to keep moving, and get this over with. I like to move it. All right. Anyways, flip it over. Does anyone still need this? Anybody? Then let's move on. Angle bisector. What's a bisector? What does that do? What does a bisector do? It divides it into by two. Okay? Bisect. Cut into two equal parts. So you cut something exactly in half. That's what a bisector does. So look at this picture. I got an angle, and I have an angle bisector that's cutting it in half. So it is a ray that divides an angle into two congruent angles. Two congruent angles. All right. Now, in the diagram to the right, what is the angle bisector? What is cutting it in half? How do you name that? Not just the point, but this whole thing is what? B, D. It's a ray, right? From B through D. So go ahead and write BD with a ray on top. Cool. So if it's a bisector, that means those two parts are now going to be congruent. So here's how you would write that. Angle ABD. Y'all see that? ABD is the top part, top half, is congruent to the bottom half, DBC. Cool. So angle ABD is congruent to angle DBC. All right? So that's bisector. Anytime you see bisector cut in half, you can set them equal and solve, just like when we did midpoint on segments. Now, angle addition. Here's how you do this. Do y'all remember when we did segment addition, where we did part plus part equals whole? Well, guess what? We're going to do the same thing with angles. Part plus part equals whole. What is the name of this left part of the angle? What three letters does it? ABD. So go ahead and put angle ABD plus the second part, this part over here, is what? DBC. So angle DBC. And that equals the whole thing, right? Part plus part. What three letters make the whole thing? A, B, C. So that is part plus part equals whole. Cool? Now, this next problem should look familiar because we did something similar to it with the segments, okay? So let's go and look at this. It tells us ABC is 40, sorry, ABD is 48 degrees. ABD, right here, 48. Okay, so I wouldn't write it down because you got to use the same picture for both of these. So just imagine, the left part is 48 degrees. Then it says DBC is 78. Well, the right part is 78. If I know this part is 48 and this part is 78, what do I do with them to get the whole thing? Add them up, because part plus part equals whole. Okay, so 48 plus 78 equals x. That's what I'm missing. What is 48 plus 78? Uh, 126 is good. Cool. Do you see part adds up to make whole? Here's where there's a little twist, little shift, right? Right over there. Oh, sorry. My throat is very dry at the moment. All right, so DBC is 74. Now, where is DBC? DBC. Is that a part or a whole? The right part. Okay? Now, check this out. ABC is 119. ABC. Is that part or whole? That's the whole thing. So instead of giving us both parts, like if you just assumed, like so now I did this on the first assignment, don't assume it's always, they're just going to always give you the two parts, right? In this case, they gave you one part and one whole, the whole. Okay? So when you're doing this, it's going to be a little different. So let's think about it as part plus part is whole. The left part, ABD, that's missing, so I'll call it X, plus the right part, DBC, which I know is 74, equals the whole thing, ABC, which is 119. Do you see how like the equation looks a little different because X is not the whole thing, X is the missing part. So how do I get X? What do I do with that 74? This time we're going to need to subtract 74. So what is 119 minus 74? 45? All right. That is it. Okay, now, up to this point, it's been kind of, look at this next problem. These next two problems, I want to make sure everyone understands how to do, and I gotta have your focus. So everyone look over here, please. Like, for real. I know your eyes are this way, but are you like looking and listening? Okay, please focus. I know this has some more expressions, or it looks like it's going to be more algebra, but it's the same idea. Part plus part is whole, equal to the whole. So I'm looking at my picture. PQS is my left part. I know that. SQR, that's my right part. But on the picture, I don't see the whole thing. But when I read, it tells me PQR is 141. PQR. That's the whole thing. I like to label my picture. PQR, the whole thing, is 141. Okay? Can y'all see that? Now you see a part, you see a part, you see a whole. Can you set up that equation as part plus part equals whole? That's half the problem. Can you set it up? Okay? Let's set it up. The left part is 13x plus 4 plus the right part, 10x minus 1, equals the whole thing 141. Could you have set that up? Could you have added part plus other part equals whole thing? Okay. So you got to be able to do that. Next part, can you solve it? What do I do when I have those two x's on the same side of the equation? Do I combine them or get rid of one? Combine them, right? So make sure everyone's awake here. Look over here. So combine these x's, 13x and 10x, add up, combine to make what? 23x. And I also have some constant regular numbers I can combine. 4 plus -1, which is like 4 minus 1. What's 4 minus 1? 3, so plus 3. Bring down equals 141. Now, can I solve that? It's a two-step equation, so what do I get rid of first? The loner is 3, so how do I get rid of a positive 3? Minus 3, minus 3. 3's cancel. 23x equals, and then 141 minus 3 is 138. Last step, how do I get rid of the 23 in front of x? Divide by 3. Sorry, 23, that is. What is 138 divided by 23? (138) divided by 23? Oh, yeah, 13x at the beginning. Oh, okay. It's on your page too. Like it's labeled in there. 138 divided by 23. Anybody? Okay, 6. So x is 6. That's great. But that's not it. What else do I gotta find? PQS. If I look on my picture, PQS is right there. So I'm gonna replace PQS. I'm gonna replace this. The x is gonna become 6. So 13x, or 13 times 6, plus 4. So 13 times 6 is what? 78. Plus 4 is 82. So PQS is 82. What about SQR? From S to Q to R is right here. Replace x with 6. So 10 times 6 minus 1. 60 minus 1 is 59. All right. Could you do a problem like that? Because I promise you, your assignment's going to have stuff like that. Part plus part equals whole, combine like terms. Okay. Here's another one like what we just did. Okay. I want to do this because this one's not labeled, and I think people mess up by not reading it. So let's read it real quick. It says DEF. Now look, D to E to F. Is that a part or a whole? DEF is the whole thing. So it's telling us the whole thing is 7x plus 4. So I put it on the outside. It's the whole thing. Then it tells us DEG. DEG is this left part. Is 5x plus 1. And then GEF is 23 degrees. Okay. So now I have a part and a part and a whole. So can we do part plus part equals whole again? So the left part, 5x plus 1, plus the right part, 23, equals the whole thing, 7x plus 4. All right, so on the left side, y'all see we can combine like terms. 1 plus 23 is 24. Bring down 7x plus 4. Now, x is on both sides. What do I do when it's on both sides? Do I combine or get rid of one? Get rid of the smaller x, which is 5x. How do I get rid of a positive 5x? Minus 5x, minus 5x. Bring down 24 equals 7 minus 5 is 2x. And now we have a two-step equation. You should be able to get rid of the loner and divide. What's the loner here? How do I get rid of that 4? Minus 4 gives you 20 equals 2x. And then to get rid of the 2, divide by 2. What is 20 divided by 2? 10. Once you get x, can you plug it back in, right? DEG is right here. 5x plus 1 is 5 times 10 plus 1, which is 51. Okay, DEF is 7x plus 4, so 7 times 10 plus 4, 74. Okay. A lot of people get stuck, okay? I'm almost done. 3 more. Okay. So, again, a lot of people get stuck, but you have 2 examples to refer back to on how to do this. You have to label it correctly. Hey, stay with me. You have to label it correctly, write it out, part plus part equals whole, combine like terms, solve for x, and then if you need to, you can plug it back in. We're going to do these last 3 real quick. Ready? Underneath number 1, write vertical angles. These are called vertical angles because they're across from each other. And vertical angles are congruent. Number 2, if they make a 90-degree angle, they're called complementary. They complement each other. And then 3, if they make a straight line, which is 180 degrees, that is supplementary. They have a supplement that adds up to 180, sorry. All right, real quick, ready, number 1. If they're vertical like this, if they're across from each other, I'm telling you right here, look, they're congruent. So what does x equal? Yeah, if they're across from each other, they're equal, so x equals 112, you're done. Okay? The only time it gets more complicated is if there's some expression, but you just set them equal. Okay? 2, complementary adds up to 90, right? You see the 90-degree angle? X plus 68 equals 90. What do I do with that 68? Subtract to get the complement. 90 minus 68 is 22. Does that make sense? Part plus part is whole. Subtract the part from the whole to get the missing part. Same thing on the last one. Part plus part, so 124 plus x equals 180. Subtract 124. X equals 56. Okay? They're supplementary because they make a straight line of 180 degrees. Okay? Now, what I'm going to do is I'm going to pass out the assignment. You have a little time today, but you'll have tomorrow to work on this. Okay? Here we go.